please welcome grantee David Sampson.
Thanks, Chad. So I'm going to begin today with posing a question. What is sleep? Think about this. We spend a vast majority of our personal lifetime cumulative experience in this fascinating state. In fact, we all know what it feels like to go into work with 3 or 4 hours of sleep under our belt, where we feel that lack of mental acuity and that downward shift in mood. In addition, you're going to spend up to 36% of your lifespan in this state. That's 25.6 years for the average human lifespan. So this truly begs the question, why do we sleep, right? From an evolutionary lens, and to answer any question, you have to look at it through an evolutionary lens. You can't eat, okay? This is a prerequisite for survival. You can't mate. We all know that sex is the engine of the evolutionary process, and that's a big no-no. You can be eaten while you're in this semi-conscious and unconscious state. So there's some serious cost to doing this for as much as we do it. That's led sleep researchers such as Ross Chafin to say that if sleep does not serve an absolute vital function, then it's the biggest mistake the evolutionary process ever made. These are bold words, but words I think worthy of consideration. The issue is confounded even more when we look at how much variability there is in the animal kingdom in terms of how sleep is expressed. So for example here, the brown bat sleeps almost 20 hours out of its 24-hour circadian cycle. This adorable little hedgehog here clocks in at 16 hours. And the giraffe only sleeps 4.5 hours out of the day. It's bizarre, but I guess if I was sleeping with my head on my ass, I would only get about 4.5 hours of sleep in a day anyway. So when we actually look at mammalian patterns of sleep, what do we see? In fact, when we do what we call phylogenetic analysis, that is controlling for the relatedness of species evolutionarily, we see that the more closely related the species is, the more similar the sleep characteristics are. So we can actually see, in the past 10 years, we've made some major strides in this, and we can actually see a few patterns emerge as to what might be the best explanation for what sleep does for us. So if you're an herbivore, you're going to sleep less than a carnivore. This is sort of intuitive, right? If you're the apex predator, you're the one setting the speed limits on what other animals are going to be able to sleep. If you have a fast metabolism, such as this common tree shrew, you're going to sleep less than animals that have a slower metabolism, such as this sloth, three-toed sloth. 17 hours out of the day. Kind of makes you want to be a three-toed sloth. And then what we also find is that on a species level, and I'll break this down for you a little bit here. On a species level, if you invest more in your immune defense, that is, on the average species level, you have greater number of white blood cells, then you're going to actually sleep longer. So this x-axis, the horizontal line there at the bottom, that's actually a log-transformed version of total sleep time. So the more you sleep, the more white blood cells you have in your body. And in fact, the inverse relationship is true for parasitism. The more you sleep, the less parasitized you are on average as a species. So what we see here is the emergence of two very critical dimensions to the problem, the puzzle of sleep. That is quantity and quality. So ecology, all these kind of big players that I just mentioned right now, ecology sets the limits on quantity, on total sleep time. Once you have that parameter set, though, within that, that's where quality comes in. And this is where primates actually shed a lot of light, perhaps, on why we sleep the way we sleep. So this will be the meatiest graph, and I'm going to try and break this down for you all. On stages 1 and 2, this is what we call light sleep. Now, in light sleep, this is, you go from the transition of being awake to this stage in light sleep, and the trade-off here is that you're actually much more aware of your surroundings in this stage of sleep. In fact, you can wake up pretty readily, especially if someone calls your name. You can wake up pretty readily in this state. The trade-off is you're not getting some of the really critical benefits of the deeper stages of sleep. The deeper stages of sleep are slow wave and then REM. When you're in stages 3, 4 there, you see those really big lines that are going up and down? That's your thalamus communicating with your neocortex. It's this cleansing motion. It's actually part of the metabolite process that clears out plaque in your brain. Really critical for you to be able to think clearly the day after you sleep. The issue is here, when you're in this stage of sleep, it's actually, your arousal threshold is actually much higher. So if someone's going to call out your name in this stage, it actually might be harder to wake up. Where you are in a stage of behavioral paralysis is REM. And we're all familiar with REM because REM is associated with dreaming, right? So REM stands for rapid eye movement. When you're in this stage, you're essentially as close to dead as you will ever be. Okay, you're actually in a state of behavioral paralysis, which from an evolutionary standpoint, if you're an ape sleeping in a tree, might be good. You don't want to be acting out your dreams while you're 20 meters in the air. So this brings us to primates, and my particular favorite primate's the great ape. So as a graduate student at Indiana University trying to figure out how I was going to make my mark, make a contribution to the field, I discovered this, well, I didn't really discover, but I came across this fascinating behavior of sleeping platform construction. And so if you're a chimpanzee and you've done a full day's foraging, full days of activity, and you're settling down for the night, you're going to find a place in the gallery forest canopy where you can scale up, on average about 12 meters, break these frame-supporting branches inward, and then form a weave. I like to call this the box spring, okay? And then you're going to take ancillary branches, you're going to break them in, they have a little bit more foliage on them, and you're going to integrate that into the weave itself. I like to call this the mattress. And then, if you want a really high-quality night's sleep, you might go up to 50 meters sometimes to get the really plush foliage, bring it back, use it as a pillow. So what we have here is functionally a tree bed, okay? And this is remarkable because all the great apes do this. Orangutans, bonobos, common chimps, gorillas. The stark contrast is no other primate does this, okay? If you're a baboon, you're going to sleep on your ischial callosities. That's a fancy word for butt pad, okay? You're going to sleep on your ischial callosities on a cliff face or on a tree branch. If you are a large-brained monkey, such as this capuchin monkey in the center, you're going to sleep prostrate on a branch. If you are a gibbon, so if you're phylogenetically closely related to us, and we heard those gibbon calls from Topher's talk, they're really awesome, but these animals are very closely related to us on an evolutionary scale. They don't use sleeping platforms. So this is what drove me to go out to my field site at Toro-Semliki Wildlife Reserve, a field site that my advisor has run since 1996. And I wanted to investigate, look into the mind of a chimp, why he or she was selecting the kinds of sites that they selected. And here, I'm clog ascending this tree, making it look relatively easy here, but I remember very intimately the first time I went out into the forest after about a week's worth of practice back in the US, literally going out once to do this. And I remember going out into the forest with my doctoral supervisor and 2 UA rangers. I had 45 pounds of equipment on my back. It took us 2 hours to find our first beautiful chimp sleep site. So I'm getting out all this equipment, and it took me about 45 minutes. I was really green. And there's a throw line and a throw bag. And the idea is that you want to throw it over the crotch of the tree. That's going to allow you to hook up your equipment to safely scale up in there, and so I could get the data that I needed. Well, after 2 throws, I get that throw line caught in the tree. And I'm thinking, okay, now I can show how resourceful I am because I brought a spare throw line. You can see where this is going. Threw it up into the tree, and it gets stuck. And as I go through a downward psychological negative feedback loop of despair, because I think I traveled halfway across the world for absolutely no reason, my friend, who was an Ugandan ranger, kicks off his gumboots, scales up this tree like you or I were walking down a sidewalk, 20 meters into the air, scales up the tree, grabs the throw bags, scales back down with a huge smile on his face, hands them to me. And it was at that point I realized I'm going to have to learn how to climb like a Ugandan ranger. So I totally did, and it really increased the efficiency by which I could generate this data. But nonetheless, for the really dangerous climbs like this one, I had to use that equipment. So, like, I'm sure Topher understands this principle, but we were literally going out on a limb to generate this data. So what we discovered up here is, in fact, chimpanzees really care about where they sleep. In fact, at Semliki, it offered a perfect opportunity because they select this one tree species called African ironwood. The genus name is Cyanometra alexandri. And they select this 8 out of 10 times, even though it's only 10% of the home range. So this was a perfect opportunity to look into a mind of a chimp. Why were they selecting this particular species? And what we discovered was it had the most bending strength, it was the most pliable, the internode distances between the leaves were actually the shortest, so it could really, remember that weave I was telling you about? It could really hook into that weave. And it even, with mosquito catching tests, it even repelled insects, okay? So Christine Delamore at National Geographic wrote this up. It was a beautiful article. And the lesson we can take here is that wild great apes really care about where they sleep. So back home at the Indianapolis Zoo with Dr. Robert Shoemaker, I wanted to push this research a little bit more. I wanted to see what happened when we manipulated the quality of sleep environments for other great apes, like the orangutans. So this is AZ. He's a fully flanged male at the Indianapolis Zoo, and AZ is a master sleeping platform builder. Okay? He would spend sometimes up to 50 minutes building a sleeping platform. And what we did was we introduced these high-quality sleeping materials, and we measured sleep physiology. Here is AZ in a REM state, right here. As far as I know, that's the only video ever recorded of an orang in REM state, I'm pretty sure. What we discovered was something actually pretty remarkable. This is that moment when I was doing data analysis in my dissertation. I was like, wow, okay, this is cool. So what we see here is that on the horizontal axis, you have sleeping platform complexity. That's when we gave them all the pillows, blankets, memory foam mattresses, sheets. We gave them all those materials, and we didn't have to teach them anything. They took at it, and they made these super beds, right? So the nights where they had access to these super beds, they actually had less fragmented sleep. So fragmentation in your sleep, that's bad. You don't want that. They had less fragmented sleep during nights where they had more complex sleeping platforms. And not only that, when we did next day touchscreen cognitive tasks, they performed with higher accuracy when they had access to these sleeping materials. So what this tells us is that great apes really care about how they sleep, and in fact, it may improve their minds. So I've talked about the great apes a little bit, but what about us? Where do we fit into the scheme of primates? And this is why I love evolutionary biology, because it's all about the comparative method. So humans are bizarre. We're bizarre for lots of reasons. But one of the things that makes us unique is, as you can see in the top there, we actually sleep the least out of every primate yet recorded. That's kind of counterintuitive, right? Because we think sleep is good. Yet, we have the highest proportion of REM sleep. By far. 25% of the night we spend in REM sleep. And remember I talked about the cost associated with low-quality sleep versus high-quality sleep? We're really vulnerable when we're in this state. So something had to happen during our evolutionary trajectory. Perhaps that transition from our Australopithecine ancestors that were in the trees. When that transition occurred and we came on the ground and we were full-time terrestrial, perhaps that was when we had this shift in sleep quality. So in fact, human sleep may be unique, and maybe the take-home point here is that for us, it's quality over quantity, okay? But before we can make this statement, I think there is an absolutely essential line of future research that has to happen. In fact, this is where I'm taking my research. At the end of this month, I'll be going to the village of Mendena in Madagascar, the Marojejy National Park, and I'll be working with a population that doesn't have ready access to electricity. Our culture is inundated with light. So I want to see how this affects sleep activity patterns in a culture that has a normal lux, light environment. And with the generous funding of National Geographic, I'll actually be going at the end of the year with a collaborator of mine, Alyssa Kertenden, who's worked for a decade with the Hadza. We'll be going out to Hadza land in Tanzania and working with hunter-gatherers in the very same environments that our ancestors evolved to answer questions about sleep phasing in human evolution. So in summary, big brains do need big beds, and as a Homo sapien, as a great ape, and as a primate, I wish you all lots of deep, slow-wave delta activity and REM, dream-inducing REM, That being said, I do appreciate you staying awake for this presentation. Thank you.